Cross-products property is what we're going to discuss, and what it deals with is really the idea of cross-multiplication. So one thing to know is that when we talk about ratios, ratios can be written in one of three different ways. They can be written in words, which means that if you might write something 1 to 2, you would say something like this out loud that's written in words. Secondly, you can write a ratio as, say, a ratio. You write it as 1 to 2, pronounced the exact same way as it is in words. And third way, which we're probably more accustomed to, is just seen as a fraction, such as slope is sort of a rise over run, if you will. How far you rise over how far you move left or right. So in this case, as a fraction format, 1 over 2. All three of these, 1/2, 1 to 2, and 1 to 2, are all different ways of writing ratios, and all of them deal with the cross-products property. All of them are equivalent and can be used this way. When we have two ratios or fractions put together set equal to each other like this is actually called a proportion. So an equation that states two ratios are equal is called a proportion. What we're going to then work with is the ideas of extremes and means. When I think of extremes, I think of the extreme cold, like it's negative 50 degrees outside, or extreme heat, like it's 120 degrees outside. Those are the extremes. Those are the far sides of everything. Geographically, you could talk about the East Coast and the West Coast. The far sides and whatever's in the middle, like the Midwest, is sort of in the means. The idea is if I pronounce this out loud, I would say A over B equals C over D. The very first thing and the very last thing that I pronounce are actually the extremes. So that would be A and D are the extremes. The things in the middle then, the B and the C, are the means. If I was to write this out sort of more in ratio form, I could actually say, hey, we're comparing A to B, and that's going to be equal to the comparison of C and D. The very first and last thing, those are called the extremes, and the two things in the middle, those are called the means. What we'll do is we'll work with the extremes and means, and specifically their products. So it says complete the table by calculating the products, or the multiplication, of the means, and calculating the products, or the multiplication of extremes. So again, the means are the ones in the middle, so that'd be 5 times 6. 5 times 6 is 30. Right here we'll deal with the middle again, that's going to be 6 times 2 times 9, which is 18. And here we have 8 times 28, which is 224. Next what we'll do is we'll work with the, I'll switch colors really fast so we can tell the difference. Then we'll work with the extremes. 3 times 10, also 30. 3 times 6, also 18. And 7 times 32 is 224. The idea, based on our observations, what do you observe about the product of means and the product of the streams? The two products are equal. The two products are equal. In other words, in a proportion, the product of the means is equal to the product of the extremes. Okay? So the idea is that when you cross multiply, when you multiply 3 times 10, you can actually set that equal to 5 times 6. That is equivalent, and it's okay to set up a proportion. In other words, from a proportion like this, if we say the product of the means would be 5x, the products of the extremes would be 2 times 20, so that would equal 40. Then what we can do is we can algebraically just solve this by dividing both sides by the coefficient in front of the x, which means that x will just equal 8. We can make up several other examples. But the idea is that you're going to cross multiply, you're going to use the cross products property to set two ratios, the cross products equal to each other. You're going to divide by the coefficient in front, and you'll actually solve for your variable. Over here, we would have x times 39. X times 39, so we'd have 39x equals 13 times 9. 13 times 9 is 117. I'll then divide by the coefficient in front, so that's divide by 39 on both sides. That would give me x equal to 3. In this case, I'd have 24 times x equals 32 times 6. That equals 192. When I divide both sides by 24, I get that x equals 8. This next example, I have 5 times x equals 2 times 24, that's 48. When I divide by 5 on both sides, you don't always get a really nice number back, but in this case it's 9.6, not a big deal. You can have integers, positive or negative. You could also end up with decimals. Now, this bottom part usually throws some students off just because things are written in a different format. And just remember that we're going to still multiply the extremes, which are the far edges, like 5 times x, and we'll multiply the means together, which would give us the 10 times 10, which is 100. Then it's still the same process. We divide both sides by the coefficient in front, and x equals 20. Again, we'll multiply the inside and the outside stuff together. That means that 300 would be equal to 25x. When we divide both sides by 25, x would equal, let's see, there are 4 25s in each 100, so that means this would equal 12. Again, we'll multiply this again, insides and outsides, so we have 5x equals 20. Divide both sides by 5. This is showing all of our work, and x equals 4. Quick lesson today on using the cross products property, the idea basically that when you cross multiply, the product of means is equal to the product of extremes.